Okay, good morning. John here. First of all, for you in the SG forum, this is the original SG motor. And you can see it has 7 devices, multi-strand coil. This is an alum battery on the input of the machine. So I'm going to start this machine. Alright, and then what I want you to do is watch what's going on here very closely. The circuit is arranged so that a bridge rectifier comes off the branch here of rectifiers and then goes to a bridge, and that bridge feeds this comparator, and you can see the green flash, and you can see what it's doing to the output battery. And this is about once every second. It's a 1 amp machine, so this is set to 1 ampere only, and of course the pulse builds up. The comparator decides between this battery and the capacitor when to fire, and so it does this continuously. So all of you that are building SG machines, you're going to have to start out at 120 milliamps to understand the principle of this machine. Now I can easily take this off the rectifier and then run right to the primary or the secondary battery here. This is a 24 amp hour wheelchair battery. So I'm going to put the meter on here so we can see where this battery is compared to what the input battery is. So you had to bear with me, I'm a one-hand cameraman, but you can see the load that this machine is pulling. It's taking advantage of the 23% mechanical energy, which you have to add into the equation when you do the COP rating. So let me get this hooked up. And see where this battery is going here. I want to make sure that you understand what the machine is. This machine charges batteries. The idea is to get the efficiency out of the machine, to get the mechanical work out of the machine. This is your free part of the machine, is the wind right now. So besides capturing all the wasted energy in this capacitor and then discharging it at the right time across the load, so you can see what it's doing with the battery. It's just pulsing the battery upward now. This is considered a deep cycle, so this is going to want to stand lower than the normal batteries. So basically this will keep this up for a while, and we'll see where this battery goes. Now the kit circuit board, which is going to be this kit right here, is exactly to the lab machine built according to the patent. Now what the patent has told you is that it's capable of recovering all the wasted energy in the machine and putting it to a second battery. And that's exactly what it's doing. So if you're pushing high current with this, you're not going to get this effect. You're going to be left out in the cold, and you're never going to achieve a COP of more than 65% if you're doing that. Because then that means that you're just heating up these devices for no reason. The machine is not about pushing current. It's about no current and how you can charge something without the current based on Tom Bearden's original theories. Okay? This is a mimic of the original 1984 Watson machine, only it's changed around so that you don't have to use a DC drive motor. So, once again, here's your primary battery. This is an Elm battery, and we'll get the meter and we'll come back here, and so just bear with me. Okay, back. This is pretty typical of an Elm battery, where an Elm battery sits. So you can see that there isn't enough energy in this battery without the use of this machine in inductive charging to do this. So you can see that it's just pulsing away at about 2.25 amps per second. Okay, so if you go on the internet and use a joule calculator, you'll see this about 31 volts. And so just use a calculator and you'll know exactly how many joules are going to this battery per second times however many minutes you're running. And that's what you want to do. You want to know what you're using in joules here. Okay, so if you look at this Elm battery, it's a lot lower than 12 volts. This is normally where the Elm battery stands, and you can see that it's an Elm battery by the white. And this is all discussed in the Crystal Lights forum on this group. So, just wanted to show you that if I can sit here and do this with the circuits that are given to you, then you should be able to do this following directions without any problem at all. You should be able to charge this battery. Now, a gel cell is going to look a little bit different on this, so I'll be back in a minute and show you that. All right. We can see once again that the Elm battery is still driving at a much lower voltage than what the secondary battery is. And you can see that you still have that 2.25 amps. Now, if you use a probe, you're going to find out this is more in a pulse. But you can see where it's pushing this battery now with this pulse. And this is a gel cell. So you don't want to really overboil this battery. So you want to cut it off somewhere around 16 volts. So you can see it pushing it up here. And if we move the meter, okay, and that's corresponding, try to get them both in here. With what's this doing? So if you're not getting these results like I'm getting here, then you've done something wrong with the circuit. So I just wanted to point these little things out to you, and I hope you enjoyed seeing the lab machine run, because that puts out some mechanical work with that size fan. It's almost a 21-inch fan. So there you go. There's the machine. There's the multi-strand coil, trigger circuit, and 7 devices, 470 ohms on the basis. Okay, thanks for watching.